The official FastMCP documentation shows remote server support, but your simple URL-only proxy keeps failing with transport errors. Here's the correct way to implement it with explicit transport specification. We'll build the properly configured proxy using the documented MCPConfig format, showing exactly why the transport field is mandatory and how to structure the configuration. You'll see the minimal working example that avoids the TransportNotSpecifiedError while maintaining full compatibility with Claude Desktop's STDIO requirements. From FastMCP, import FastMCP. Create a proxy to a remote server. Proxy equals FastMCP as proxy. https://example com/mcp/ssc. Name equals remote server proxy. If name equals main. Proxy run. Runs via STDIO for Claude Desktop. This demonstrates the transport proxy pattern with explicit configuration requirements, creating a local STDIO bridge to remote MCP servers that enforces upfront transport declaration. The core concept involves protocol translation through a mandatory configuration step where you must specify either SSE or HTTP transport. The proxy won't operate with just a URL. This differs from generic proxies by requiring explicit transport binding during initialization, ensuring predictable behavior across different MCP server implementations. The pattern works by first validating a complete configuration containing both connection details and transport specification, then establishing a bidirectional message pipeline between STDIO and the declared remote transport. The proxy handles all protocol conversion and message framing, but only after you've explicitly declared the transport mechanism through either a config dictionary with transport field or a pre-configured client object. This design enforces transport awareness at creation time while keeping the operational logic transport agnostic during runtime. This approach solves the problem of environment-constrained MCP integration, where clients can only use STDIO but need remote server access, while maintaining strict protocol compliance. The explicit transport declaration prevents ambiguous connection attempts and follows the emerging MCP configuration standard. The trade-off is slightly more verbose initialization in exchange for predictable behavior and standards compliance, particularly valuable in AI tooling, where transport reliability directly impacts user experience. The pattern works best when you need to bridge between constrained local environments and properly configured remote MCP services. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for MCP client and proxy creation. Note that actual usage requires explicit transport specification, either via a client object or a config dictionary with mandatory transport field minimum valid. URL, transport, SSE. The shown URL-only configuration is incomplete and will raise TransportNotSpecifiedError per MCP specification. For production use, either pre-configure a client instance or provide a full config dictionary following the MCPConfig standard format. Create a proxy to a remote server. Proxy equals FastMCP as proxy. This creates a FastMCP proxy connection to a remote MCP server, but the shown URL-only configuration is incomplete. FastMCP requires explicit transport specification, either SSE or HTTP, and will raise TransportNotSpecifiedError without it. The correct minimal configuration uses a dictionary format following the MCPConfig standard. A Python. Proxy equals FastMCP as proxy. Config equals URL https://example com/mcp/ssc. Transport SSE #mandatory field. Name equals remote server proxy, hash debugging identifier only. For production use, the preferred pattern is passing a pre-configured client instance instead of raw configuration. The name parameter provides debugging context but has no functional impact. https://example.com/mcp/ssc. This URL specifies the MCP server endpoint, but requires explicit transport configuration to work. FastMCP mandates either a pre-configured client instance or a config dictionary with both URL and transport type, typically SSE or HTTP. The shown URL-only format will raise TransportNotSpecifiedError. Production code must use either Python #1 explicit config config equals URL https://transport SSE #2 preconfigured client equals client URL equals https:// transport equals SSE. Name equals remote server proxy. Debugging identifier only. The name parameter assigns a human-readable label to this proxy instance, visible in FastMCP's admin UI and logs. It has zero functional impact, but becomes critical when running multiple proxies simultaneously, as it defeats ambiguity between auto-generated IDs like Proxy1 and Proxy2. For production use, you must also explicitly declare the transport protocol, SSE or HTTP, in the configuration. This example omits that required specification. This closing parenthesis terminates an incomplete FastMCP as proxy call that will fail at runtime. The URL-only configuration is invalid. FastMCP requires explicit transport specification via either a client object or a config dictionary with a transport field either SSE or HTTP. Without this, execution raises TransportNotSpecifiedError. For correct usage, provide a full config. Config, URL, transport, SSE, or use a pre-configured client. The name parameter is purely for debugging. If name equals main. Python's standard entry point guard prevents proxy.run from executing during imports, ensuring the FastMCP proxy only starts when this script runs directly. This pattern is mandatory for reusable modules. Without it, importing this file would automatically initialize the proxy, which requires explicit transport configuration, either SSE or HTTP, to function correctly. The guard ensures the proxy only starts when intentionally executed as the main program. Proxy run. Hash runs via STDIO for Claude Desktop. This starts the proxy server but demonstrates an incomplete configuration. FastMCP requires explicit transport specification, either via a client object or a config dictionary with a transport field e.g., transport, SSE, or transport, HTTP. Without this, proxy run raises TransportNotSpecifiedError, as the library cannot infer the protocol from the URL alone. The name parameter is purely for debugging and has no functional impact. For a working example, you must either pass a pre-configured client or include the transport in the config. FastMCP proxy initialization. The asProxy method creates a local bridge to remote MCP servers, but this minimal example omits the mandatory transport specification required for actual operation. The shown URL-only configuration will raise TransportNotSpecifiedError when executed, as FastMCP requires explicit transport declaration via either a client object or config dictionary with transport field. Production usage demands either a pre-configured client or minimal config like URL, transport, SSE.
The proxy that appears complete must first declare how it will speak